Hello, everyone. Good morning, ladies and gentlemen, and welcome to the AGI Leap Summit, brought to you by Super AGI. As we gather here today, we will be standing on the edge of new era when it comes to artificial intelligence. My name is Haneen Salah, and today I'm going to be your host for this amazing Leap Summit, and we will be presenting to you a groundbreaking event where there's a lot of researchers, a lot of amazing events. So let me start by saying what is Super AGI. Super AGI is a leading AI technology striving for a future where AI enhances humanity, and we're not only the only ones who do this, but a lot of amazing researchers who will be joining us today. This summit aims to bring researchers and the dreamers from different parts of the world to a single forum. This summit is about showcasing the latest breakthrough and the latest artificial intelligence research and all the breakthrough that we have came to this era and day, encouraging a collaborative dialogue among leading minds in AI. So as we move on, today's summit will be a testament for the AGI vision. So the event we're having in today, featuring the area of sessions, we will be highlighting the latest AI researchers and researches when it comes to AI safety, protocols, technological breakthrough, and many more. So, as we delve into today's agenda, expect to be engaged by the brightest minds today in the field of sharing their research, insights, and vision for AI. We will kick off this session with 10 spotlight researchers' presentations, followed by 5 amazing parallel tracks. These parallel tracks will include agent based systems, reasoning and intelligence, modalities, and AI safety, security, and performance, and last but not least, AI survey and applications. Each session is designed to not only showcase cutting edge development, but also to encourage dialogue and collaboration among all of us here today. So, today's spotlight will shine on groundbreaker research that tackles some of the most amazing presenting challenges in the AI world and opportunities as well in the field of AI. So, some of them would include in the research today enhancing AI, understanding and complex data escape, ensuring AI system operate with secure ethical frameworks. And we have moving on, exploring the integration of sensory modalities, create more intuitive AI, and pushing the limits of AI problem solving and decision making. So those main 5 topics what we will be trying to cover today with our research. And I am more than certain that we're going to have an amazing session because there's amazing minds, amazing people who work behind this amazing Leap Summit. But to give you more about this event and Super AGI and our AGI Leap Summit, I would like to welcome our upcoming and next co-host with me is Nachan. So Nachan, the platform is yours. Hello, Nishant.
Hi, Hanin. Thank you for inviting me and introducing me to this wonderful turnout we have today. And hi, everyone. Hi to all the attendees and all the researchers. It's my pleasure to, you know, kick off this session and discuss bring together brilliant minds from all parts of the world to discuss AGI. So I have prepared a little presentation which will kind of give us a brief idea about why are we doing this and what are we doing as part of Super AGI and what is our research interests. So without wasting further um seconds, let me just start with sharing my screen. So yeah, folks, uh, first of all, happy Leap Day. February 29th has always captured my imagination. This magical day that comes almost every 4 years. And there's something special about it. And there couldn't be a better day to celebrate the leap towards AGI than the Leap Day itself. Looking at the turnout today, I can feel that we have all agreed to step into another dimension, and it feels like amazing things are about to happen. But before we go any further, let's try to understand why are we really interested into AGI, right? Um Anybody from the audience would love to share their opinions in the comment box? And guys, feel free to just make it a little bit collaborative, and we would love to hear what motivates everyone to pursue this goal. Yeah, that's a great answer, because nobody expects knows what to expect from AGI. So as researchers, we are kind of resonating with the explorer mentality to go where nobody has ever gone. Yes, yes, I think a lot of great answers and a lot of real ones as well. Uh, but yeah, I let me share a perspective from our side, and we got our answer when we started to when we rephrased the question a little bit. We asked ourselves, how will humanity benefit from AGI? And when the question is as big as humanity itself, we had to look at a longer time frame. So So when you think about the past, 100 years, you'll realize that every technological revolution has always been about liberating humanity from one or the other form of labor. Industrialization was about freeing us from physical labor. Software and internet revolution was about freeing us from information labor. We no longer have to memorize things. We no longer have to do complex calculations, and information is right at our fingertips. But the, we are not completely free from labor yet. The major form of labor which we do today is cognitive labor. While it may not look like labor because it's kind of not very uh, repetitive, but it's still some combination of some repetitive tasks which we do on a daily basis. And we are in the end game now, because AGI is going to free humans from cognitive labor, which is the last piece of this puzzle, right? So the key takeaway is that economists have always seen labor as a driver of output, right? But however, I think, and we at Super AGI think, that it's more of a constraint. And when all these constraints are lifted off, the bottom left hand equation of productivity, which depends on labor and capital, will change into something which will only depend on A, which is the technology factor, and K, which is the capital. That means AGI is the way towards making our life easier and freeing us from work and make money from AGI, which Russell mentioned. So all of your answers are correct, and obviously, it's interesting to see what the future holds from uh, with AGI. So before we go deeper into some of the technical areas which Super AGI is working on, and before we take that leap into the future, it's important to take a moment to revisit our past. And we would love to give you a brief walkthrough of our journey, which started with the open source framework, which called which was called Super AGI framework. So the greatest infra projects, since Super AGI is also seen as an infra kind of for agents, right? The greatest infra projects were not uh, built because somebody wanted to build infra. They were built because somebody was trying to build something, some application, and they realized that some key core infra is missing. MongoDB, interestingly, is a great example here. So they wanted to build a cloud architecture which is based on entirely open source components. They were unable to find any existing database that met their principles for the ideal cloud architecture. They finally decided to create their own database, and the rest is history. Our journey is also similar. So, we were trying to build some products with generative AI capabilities. And that was the moment when we realized that all the existing framework are not production ready. So we released our first framework on GitHub, and it was the first production ready framework to build, run, and deploy autonomous agents. So, to sum up, we were born and raised at GitHub with participations from developers and researchers all across the world. And since we were the early movers in the agent world, we were also the first one to realize the limitations of the framework. There were namely two major limitations. The first was multimodality, right? Uh, so most agentic frameworks, including AutoGPT and LangChain, were built on tools which were just calling some APIs. And however, like the real world is not made out of APIs. It's made out of software which are designed for humans, right? So this realization led to something which we called as AutoNode. It's our first attempt towards multimodal agents. I'll just like to play a brief video so that all of us can see AutoNode in action. As you can see that the task in this demo, we gave the framework a task to basically reply to all the unread emails, and the auto node is actually typing label unread and filtering all the conversations, picking out the first email, and it will be drafting a reply. So this kind of, what are the implications of this, right? Right now, if you're trying to call some APIs, let's say Facebook API for Instagram or Twitter API, you will always be guardrailed by this big tech, right? But what AutoNode enables is uh, interaction with the digital world in the same way how human interacts, right? So that kind of creates a platform where AI agents can come at par with humans. So the second piece of the puzzle, the second limitation which we realized was the lack of truly agentic models. What we mean by agentic models is that uh, you cannot actually solve AGI by just scaling laws, adding larger data sets, building larger models. Your agents uh, need to be trained on data which is truly agentic. What I'm saying here is that the models and frameworks need to have very intimate kind of interaction in order to solve AGI. In our vision of AGI, I need frameworks and models will have to complement each other. For example, models are stateless; they cannot have memory. Frameworks will need to jump in here and you know come up with that memory module. And frameworks are just software, so they cannot think and reason. That's where large agentic models come in, right? So SAM is our first uh, large agentic model. SAM actually stands for small agentic model because it was just 7 billion parameters, and with that what we achieved was it was able to come up with better reasoning than GPT 3.5 and Orca 2, which are obviously larger models. And the implication of this was that we kind of developed an in-house capability to impart any desired capability to any smaller model. So that uh, implies that whenever we are trying to build a 100% autonomous system, most of the places we can just get away with using some generic LLM. But in places where we need truly agentic kind of reasoning, we can call our own LAMs, which are large agentic models. And again, we took this to the multimodal area. We launched our multimodal model called Beagle, which was surpassing all open source models. It was still lagging behind GPT-4 Vision, and that is what kind of led us to the next challenge, which is we still have to find a name for that. But I'm just sharing the sneak preview of our next multimodal model, which we are going to release in the next month. So this model was the idea behind this model was to add a time dimension to the multimodal models. So the training format looked like this. You were given two images, the previous image and the action which was performed, and the next image. And the model was supposed to answer the next best action for a given particular goal, right? So if you see on the left hand side, what we did was we tried to confuse our model. Instead of giving it the, uh, we are mentioning here that the action was to click on search button, and and we are asking for the next best action. So the model was, when the training happened, the model was seeing a lot of data points. Whenever you click on the search button, the next step is to apply, click on something called as apply filter or some other kind of button. But in this case, the answer is to click on the recommended setup button, because actually there is no apply filter, because we never actually clicked on the search button. But that is a testament that the model is combining both the text as well as the image to come up with a next best action. On the right hand side, you will see a happy case where we gave the right previous action, which is click on the job titles button, and the next icon was to next best action, which the model predicted was to click on the search for a job title tab, uh, so that you can actually type something or select something. So the next and last frontier of all of this is probably a multi-agent system, right? Where individual models, be it text-based LLMs or multimodal LLMs or our own large agentic models or some frameworks, all of them kind of collaborate to solve real work, so that humans can go and chill. So just to share a sneak peek of some of the architectures which we were brainstorming. So for example, on uh, this architecture is kind of uh, a combination of models, agents, as well as humans, right? So if you see on the left hand side, a user is trying to hire a AI employee which does the job of a SDR. Now, SDR is basically a sales development representative, right? So when a conversation goes to a SDR, it basically sends that conversation to a set of agents, and before reaching those set of agents, the conversation goes to a memory manager, which kind of picks the relevant facts and preferences of the user and supplements the chat prompt. Now all of these agents, they are like different parts of the human brain, right? One guy is responsible for understanding what task needs to be done. One guy is responsible for answering if there is an ETA related query. One guy is responsible for ensuring that payment is paywall is not hit, right? And one guy is responsible for making sure the responses are safe and compliant. So all these different agents, mini agents, will give their own reasoning, which is thought, and a recommended action. and then the master agent, which will handle all these recommendations to generate a user reply, and it will also generate approved actions. So maybe it can just ignore what some of the people are saying, right? And in most cases, most of these mini agents will just not suggest any action, because maybe the query was not about ETF, so the ET agent will not recommend any action. Now, when these actions get pushed towards a shared task table, which is like a ground truth of all the tasks which, like, the master agent has communicated to the end user, these tasks are getting dispatched to a task executor agent. So on the right part of the dotted area is the execution side, right? This task executor agent is again a multi-agent system in itself. But the key insight is that the central multi-agent system is kind of common for all kind of AI employees, be it graphic designer, be it market researcher, be it SDR, right? But the end part is kind of very specific to SDR, because maybe in this case SDR was giving the task. So that's the kind of decoupled architecture which will kind of you know, imitate AGI in some ways in the given future. So that's our last uh, uh, piece on how we are trying to look at AGI, right? And happy to take any further questions you guys have. Would love to. I'm dying to wait to jump into the spotlight research paper, but uh,
Hello, hi, Nishant.
hey, hey.
Hey, hey, hey. So thank you so much for this amazing talk and this amazing introduction to AGI. So moving on, we will be going on to our spotlight researches, where we will be talking to our top 10 researchers. Will be introducing their research, their presentations, and what so far they have done for the field of AI. So thank you again, Nishant, for amazing introduction to Super AGI, and see you guys on the next session.
Yeah, thank you, Anil, thank you, everyone, and hope to see a great, fun session, and wish you all of you happy leap year again. Bye.
Thank you, Nishant, and thank you everyone for your amazing questions. And